So here we have our anatomically correct human being. Anyways, the nervous system can be split into two parts. One, the central nervous system. Now, the central nervous system, CNS for short, is made up of the brain. And now the brain is like a computer. It sends out orders, it takes in information, and then it processes said information. It is what makes you, you, in a sense. And believe it or not, without it, you would die. Now, the CNS also has the spinal cord, which is like a messenger of sorts. It relays messages between the brain and the peripheral nervous system. Speaking of which, the peripheral nervous system is essentially everything else in your body. The movements, the organs, the blood, etc. It is also split into two parts, first being the somatic nervous system. So the somatic nervous system is what allows you to wiggle your fingers, to go for a run, to type this script, just to move in general. Also, the somatic nervous system helps us feel things. That's concrete, that's grass, and that's the sun. Without the somatic nervous system, we would be effectively crippled, which, not so fun fact, Stephen Hawking was affected by a disease called ALS that prevented his somatic nervous system from communicating with his central nervous system, leading to muscular atrophy and confining him to a wheelchair. The other half of the peripheral nervous system is the autonomic nervous system. Think about it like this. Autonomic sounds like automatic, and so it's everything our body does automatically. But what exactly does that entail? Well, on this fine afternoon, under the blistering heat of a raging inferno, you may find yourself dripping with sweat. But why? Homeostasis, maintaining balance within our bodies. Our body's sweat glands release sweat that evaporates to cool down our bodies, thus maintaining its ideal lower temperature. That is the point of the autonomic system, to keep our internal processes running automatically by maintaining ideal conditions. However, it is not that simple. The autonomic system is unfortunately further divided into the sympathetic and parasympathetic nervous systems. Pretty much, the sympathetic system activates during times of stress, putting us into a fight or flight state where we have heightened senses. Meanwhile, the parasympathetic system is the exact opposite, and it deals with things like digestion and normal heart rate when our bodies are just chilling. Without the nervous system, we would just be a useless sack of organs, so I guess that's something to be grateful for. Now that we know about the nervous system, we need to actually know how it works. How does our body communicate with itself? Well, to find out, we'll have to look at a neuron. So here is a typical neuron, and on the left, denoted by a smiley face, is a neurotransmitter. And so what will happen is this neurotransmitter will come along and attach to the dendrites. And now the dendrites have specialized receptors to which neurotransmitters can bind to, thus allowing it to release its message. Once bound, the neurotransmitter will send out its message as usually an electrical impulse that enters the body of the neuron. And now the body and the nucleus of a neuron is collectively known as the soma, and it's responsible for keeping the neuron alive. Once the message reaches the body, it will then travel through the axon. And it is worth noting that the axon is encased in a myelin sheath. You can think of the sheath like a fiber optic cable. It provides protection to the axon while also enhancing the speed in which the message goes through. Once passing through the axon, the message will then go on to the axon terminals, to which it is released into, say, another neuron. But how exactly does the axon terminal send out its message? To find that out, we will also have to look within the axon terminals. So here's a diagram of an axon terminal, and now it is a lot of jargon there, but to put it simply, there are synaptic vesicles that hold certain neurotransmitters. When the message from our neurotransmitter comes in, it'll signal for the release of a certain neurotransmitter. This neurotransmitter is then released into the synaptic space, which is then attached to another dendrite, and the cycle repeats once again. Pretty simple, right? Many people may underestimate the sheer bulk and complexity of our neurons. It is easy to understand it on a one-to-one scale, but there are billions of neurons with trillions of connections in our brain alone. And in each and every one of them, they are constantly adapting and changing as we learn and develop new habits. It is a fascinating process, one that simply cannot be explained by words. So here's a video.
What you're looking at here are two neurons under the microscope that I've filmed. And if you wait really patiently, you'll be able to see them connecting to one another.
At this point, you're probably wondering, what exactly are neurotransmitters? Sure, they're communicated between neurons, but what do they actually do? Well, in short, they're like command prompts, sending signals to our brain that ultimately causes them to take action. There are many neurotransmitters, but mainly it comes down to five important ones. Dopamine, happiness. Say you're eating sugar and your brain is like, this is pretty good. It'll release dopamine to make you feel happy and cause you to be more likely to repeat the action.
And serotonin is a neurotransmitter that helps you to sleep.
Oxytocin, love. It brings about feelings of love between lovers. It also does help with childbirth. Noradrenaline slash adrenaline. They are pretty much identical in purpose in that they induce the fight or flight response. But what is the fight or flight response? It's been mentioned several times, but what exactly does it do? Well, to see it in action, I have to go scare some people.
Oh, you're coming. You're up here.
What do these two victims have in common? Beyond the obvious shock, what physiological shenanigans are going on? Well, in that brief moment of panic, where their brains detect an apparent threat, their amygdala signals for the release of noradrenaline and adrenaline. Our bodies beat faster as our blood vessels dilate, allowing more oxygen into our muscles and our brains to make us think and move quicker. Our liver produces more glucose to increase our energy, anticipating a potential life or death scenario. Our bodies are now primed to either fight for their lives or to run for their lives. At least until they realize it's just me. Afterwards, everything simply dies down. And there you go. These five neurotransmitters are integral for keeping us us, defining who we are as people and making sure we can feel things. What a lovely bunch of things.